The year 2025 has been a remarkable one for science and technology, with several groundbreaking discoveries pushing the boundaries of what was once thought possible. From revolutionary advancements in quantum computing to major progress in renewable energy and medicine, these breakthroughs are shaping the future at an unprecedented pace. Some of these innovations solve long-standing scientific challenges, while others introduce new possibilities that were unimaginable just a few years ago. We will explore 5 of the most astonishing scientific advancements of 2025, looking at their significance, how they work, and what they mean for the future. Whether it's the rise of practical quantum computing, AI-driven healthcare, or fusion energy making strides toward becoming a reality, this year's discoveries are changing the landscape of science and technology. 1. D-Wave's achievement of quantum supremacy.
D-Wave quantum computer has solved an important, real-world problem remarkably better, faster, and with greater energy efficiency than possible with a classical computer.
Quantum computing has been a field of intense research for decades, promising to solve problems that classical computers could never hope to tackle. In 2025, Canadian quantum computing company D-Wave made headlines by claiming to have achieved quantum supremacy. This means their quantum processor solved a problem that no classical supercomputer could realistically solve within a reasonable time frame. The milestone is considered a significant leap forward in computational science. D-Wave's breakthrough came from its quantum annealing chip, which successfully simulated the behavior of complex magnetic materials in record time. The same problem would have taken even the world's most powerful classical supercomputer nearly 1,000,000 years to complete. This advancement proves that quantum computing is not just a theoretical pursuit, but a practical tool for solving real-world problems in areas such as pharmaceuticals, materials science, logistics, and artificial intelligence.
Advantage 2 annealing quantum computer solved a complex material simulation problem in 20 minutes. Not only did our system solve this problem much faster than a classical...
Quantum annealing is particularly powerful in solving optimization problems, making it useful in industries like finance, supply chain management, and drug discovery. For example, in drug development, quantum computers can simulate molecular interactions at an unprecedented level, allowing scientists to design new medicines faster and more efficiently. This means the potential for finding cures for diseases could accelerate dramatically. Despite this breakthrough, quantum supremacy remains a hotly debated topic. Some researchers argue that classical algorithms might still compete with quantum machines in specific tasks. However, what is undeniable is that D-Wave's achievement represents a significant milestone in the evolution of computing. It signals that we are on the cusp of a new era where quantum computers will soon become essential tools in tackling some of humanity's most complex challenges. 2. Microsoft's Majorana, one chip, the future of quantum computing.
Introducing a breakthrough in quantum computing, the Majorana 1.
While D-Wave has demonstrated the power of quantum annealing, Microsoft has taken a different approach by focusing on making quantum computing more stable and scalable. In early 2025, Microsoft unveiled its Majorana 1 chip, the first quantum processor to use topological qubits based on Majorana particles. This development could solve one of the biggest problems in quantum computing: qubit instability.
This is not a work of science, it's a work of science and art.
Qubits, the fundamental units of quantum computation, are extremely fragile and prone to errors. They require near-absolute zero temperatures to function and are highly susceptible to environmental disturbances. Microsoft's Majorana 1 chip introduces a new class of qubits called topological qubits, which offer greater stability by storing quantum information in a unique way that makes them resistant to errors. This could make quantum computers much more practical and scalable.
Microsoft has made a giant leap in quantum computing with the development of the Majorana 1, the world's first quantum chip powered by a revolutionary new class of materials.
The Majorana 1 chip is built using a material known as a topoconductor, a hybrid of superconductors and semiconductors that allows the creation of stable Majorana zero modes. These exotic particles have long been theorized but were difficult to prove experimentally. Microsoft's research team successfully demonstrated the presence of these particles, marking a major leap toward making quantum computing a reality on a large scale. If successful, the Majorana 1 chip could revolutionize fields that rely on complex computations such as climate modeling, materials science, and artificial intelligence. With its stability and efficiency, it could lead to breakthroughs in encryption, making current security methods obsolete while also enabling the development of quantum-resistant encryption algorithms. 3. AI in cancer research. The Olivia Newton-John Institute's breakthrough. Artificial intelligence has made significant inroads into various fields, but perhaps its most life-changing impact is in medicine. In 2025, researchers at the Olivia Newton-John Cancer Research Institute in Melbourne, in collaboration with Hewlett-Packard Enterprise, made a major breakthrough in cancer treatment using AI. They developed a system capable of creating digital twins of tumors, virtual models that allow doctors to simulate different treatment options before administering them to patients.
This advancement is particularly important in oncology, where treatment often involves a trial-and-error approach that can be ineffective or have severe side effects. With AI-generated digital twins, doctors can now test multiple treatment combinations in a virtual environment and identify the most effective approach for each individual patient. This means cancer treatment can be personalized like never before, potentially improving survival rates while reducing unnecessary side effects.
Beyond cancer, this breakthrough signals a broader shift toward AI-driven medicine. From diagnosing diseases to discovering new drugs, artificial intelligence is transforming healthcare at an unprecedented pace. The integration of AI in medical research ensures that treatments will become more precise, reducing trial-and-error approaches and improving patient outcomes. As the technology advances, AI could become an essential tool in curing not just cancer, but many other life-threatening diseases. 4. Turning CO2 into fuel, a solar-powered breakthrough.
What if I told you AI could now process images at the speed of light using a chip smaller than a grain of salt, or that scientists have created a solar-powered reactor that pulls carbon dioxide straight from the air and turns it into fuel?
As the world grapples with climate change, scientists are searching for innovative solutions to reduce carbon emissions. In 2025, researchers at the University of Cambridge made a groundbreaking discovery: a solar-powered reactor capable of converting carbon dioxide, CO2, from the air into usable fuel. This system mimics natural photosynthesis, using sunlight to transform CO2 into hydrocarbons like ethane and ethylene, which can be used as fuel.
At 12, we turn CO2 into products that are currently made from fossil fuels. Everything from aviation fuel to the building blocks for plastics and even your running shoes.
The reactor operates with high efficiency thanks to copper nanoflowers and a perovskite-based artificial leaf. Unlike traditional carbon capture methods, which store CO2 underground, this technology actively removes it from the atmosphere and converts it into valuable energy sources. This could be a game changer in the fight against climate change, as it provides a sustainable way to reuse excess carbon instead of letting it accumulate in the atmosphere. If scaled up, this system could power industries that are currently dependent on fossil fuels. For example, aviation and shipping, sectors that are difficult to electrify, could use these synthetic fuels as a cleaner alternative to conventional fuels. This would drastically cut down carbon emissions and make energy production more sustainable.
Power sources, offering a promising solution for renewable chemical production and addressing the challenge of CO2 emissions.
While challenges remain in making the technology commercially viable, the potential impact is enormous. By integrating this system with existing renewable energy sources, we could create a circular carbon economy where CO2 emissions are continuously captured and repurposed. The Cambridge team's breakthrough represents a major step toward a future where greenhouse gases are not just a problem to be managed, but a resource to be harnessed for clean energy.
5th record-breaking nuclear fusion experiment. For decades, nuclear fusion has been considered the ultimate energy solution, offering limitless power with no greenhouse gas emissions and minimal radioactive waste. However, creating a sustained and stable fusion reaction has been one of the most difficult challenges in physics. In 2025, researchers at the West Wendelstein Experimental Stellarator Tokamak facility in France achieved a groundbreaking milestone by maintaining a fusion reaction for 1,337 seconds, nearly 22 minutes, setting a new world record.
This isn't just a new number on a scoreboard. It's a game changer in the quest for practical nuclear fusion energy. EAST is part of a bigger goal to replicate the process that powers the sun. Fusion, the same reaction happening in the sun.
Nuclear fusion replicates the process that powers the sun, where hydrogen atoms fuse to form helium, releasing massive amounts of energy. Unlike nuclear fission, used in current power plants, fusion does not produce dangerous, long-lived radioactive waste. The challenge has always been sustaining the reaction at the extreme temperatures required, over 100 million degrees Celsius, while keeping the plasma stable. West's achievement was made possible by advancements in superconducting magnet technology, improved plasma containment methods, and the use of tungsten as a plasma-facing material. This experiment demonstrated that fusion reactions can be sustained for longer periods, bringing us closer to building commercial fusion reactors.
So, what exactly is nuclear fusion, and why is everyone so excited about it? Well, fusion is essentially the opposite of nuclear fission, the process we use in today's nuclear power plants.
The implications of this breakthrough are immense. If nuclear fusion becomes a viable energy source, it could eliminate our dependence on fossil fuels, providing clean and virtually limitless power. This would solve many of the world's energy problems and significantly reduce carbon emissions. However, significant engineering challenges remain, including scaling up the technology for continuous, large-scale energy production. Even so, West's record-breaking experiment marks a critical step toward achieving fusion energy and creating a future powered by clean, abundant electricity. A new era of scientific innovation. The breakthroughs of 2025 showcase the incredible progress humanity is making in science and technology. Quantum computing has taken a giant leap forward with D-Wave's quantum supremacy and Microsoft's Majorana 1 chip, paving the way for solving complex problems that were previously impossible. AI-driven cancer research is revolutionizing how we diagnose and treat cancer, potentially saving countless lives. Meanwhile, environmental innovations like solar-powered CO2 conversion and nuclear fusion bring us closer to a sustainable future where clean energy is abundant and accessible. What makes these discoveries even more exciting is their potential for real-world applications. Quantum computing could unlock new medical treatments, financial models, and artificial intelligence capabilities. AI in medicine is already proving its worth by personalizing treatments and accelerating drug discovery. Carbon capture and fusion energy could provide long-term solutions to the climate crisis, reducing our reliance on fossil fuels and mitigating global warming. While challenges remain in implementing and scaling these technologies, the progress made in 2025 proves that we are on the brink of a new era in science. The next few years will determine how these breakthroughs shape the future. But one thing is clear, the pace of innovation is accelerating. Humanity is stepping into a future filled with possibilities, and the discoveries of today are laying the foundation for a world that is smarter, healthier, and more sustainable than ever before. As we continue to push the boundaries of what is possible, the only limit to scientific progress is our imagination.